Hey everybody, so we are on to day 2 of the 5.6 notes. It's just an extension off of the quadratic formula. As a reminder, the quadratic formula is right here, the opposite of b, plus or minus b squared minus 4ac all over 2a. And again, the a value is always attached to the x squared, the b value is attached to the x, and the c value is the constant. We can only use the quadratic formula when our quadratic is set equal to 0. Mindy, get away from me. That is my dog. Okay, so the discriminant is a certain part of the quadratic formula. The discriminant is the part that is underneath of the square root. Now, key way that I phrase that is it's the part that's underneath of the square root. So it's only this part. It's not the square root itself. So the discriminant is b squared minus 4ac. If you can hear that, my dog is nonstop licking my hand right now. I'm sorry. It's very annoying. Mindy, go away. Okay. So the discriminant, what it does is it determines how many and what kind of solutions you will get. Now, the discriminant is located underneath of the square root. So if we have a positive discriminant, that would be like taking a positive square root, like the square root of 4. So what is the square root of 4? Well, it's plus or minus 2. So how many solutions do we have? We have 2 solutions, positive 2 and negative 2. So 2 solutions, and they are both real solutions. Okay, next. If we have a discriminant that's negative, what if we had the square root of negative 4? So we took b squared minus 4ac and we got negative 4 underneath of that square root. Well, now this is really I square roots of 4, plus or minus I square roots of 4, excuse me. And the square root of 4 is 2, so it's plus or minus 2i. So again, we do have 2 solutions. But now, instead of real solutions, they are imaginary. Again, because that discriminant is underneath of the square root, if I have a negative number underneath of the square root, it's going to be an imaginary number. And last but not least, it is possible, like yesterday in our notes, I believe, we got an example where the discriminant, number 3 on the notes yesterday, I believe it was 0. So if we have the square root of 0, well, the square root of 0 is 0. So that gives us one solution, and is 0 a real or imaginary number? Well, it's real. So if we look at just the discriminant, it can tell us if we have 2 real solutions, 2 imaginary solutions, or 1 real solution. And again, the discriminant is located underneath the square root, and it is b squared minus 4ac. Okay, our first 2 examples say, find the discriminant of the quadratic equation and give the number and type of solution. So again, the discriminant is only telling us to find b squared minus 4ac. So in example 1, my quadratic is by itself, and it's set equal to 0. So my a value is attached to the x squared. There's a 1 out there. My b value is 4. And my c value, the constant on the end, is 29. Okay, so now what we need to do is just plug that in. B squared, 4 squared, minus 4 times a, which is 1, times my c value, which is 29. Well, 4 squared, that's going to give me 16, minus 4 times 1 is 4. And 4 times 29, if you punch it into a calculator, you should get 116. So 16 minus 116 is negative 100. Now, my discriminant is negative. So if my discriminant is negative, what does that tell me? Well, it tells me I have 2 solutions, and they are imaginary. Again, they are imaginary because my discriminant is underneath the square root. If you have a negative underneath the square root, you are going to get 2 imaginary solutions. One thing I didn't touch on before is, why is it 2 real and 2 imaginary solutions? Well, again, a square root, if I take the square root of, we'll go right here. If you take the square root of 16, that's not just 4, it's positive 4 or negative 4. So that's where the two real solutions come from, because one's a positive and one's a negative. Okay, my next example. I want to move all of my variables to one side. Now, it doesn't technically matter which way you move your variables. I'm going to move them to the side that'll make my leading coefficient, my first number, positive. In other words, what will give me a positive amount of u squareds if I subtract 3u squared or if I plus 2u squared. So if I plus 2u squared and plus 2u squared, then I'm going to get 5u squared, and that's easier to work with. So these cancel. Now we have 5 equals 5u squared minus 10u. And now what do we need to do? Well, all we got to do is subtract 5 minus 5 minus 5. And we get 5u squared minus 10u minus 5. Now, a lot of people might say, well, Mr. Adler, you could take a GCF right now. Yes, you could. You could factor out a GCF and get 5, parenthesis, u squared minus 2u minus 1. But that's not what I'm trying to do right now. I am only trying to find, again, the discriminant and then see what type and number of solutions I have. So again, I got to find what my b squared minus 4ac is. Well, my a value is 5, my b value is negative 10, and my c value is negative 5. So I'm going to get negative 10 squared minus 4 times 5 times negative 5. Well, negative 10 squared, so it's negative 10 times negative 10 should give you 100. I got to erase that. 100. Now, I'm going to multiply these three numbers together. Remember, it's negative 4 times 5 times negative 5. Well, negative 4 times 5 is negative 20. So this times this gives you negative 20. Times this would give you a plus 100. So we get 100 plus 100 is 200. Now, if we look back, 200, that's a positive number. So I'm going to get two real solutions. So your answer is, your discriminant is 200. And what does that tell us? That we get two real solutions. Mindy, go away. For the love of God, dog. Sorry. Yep, that was her who just snorted like a pig. Again. Okay, now we are on to word problems with quadratics. These look a lot harder than it actually is. So, for most of these, we will be given an equation. Mindy, Kennel, go away. Go. Get away. Thank you. Okay, sorry about that. So again, we will be given the equation. So you will never, ever need to memorize either this or this. However, you will need to know what things mean. So the negative 16, so that's when things are dropped or thrown. It's negative because, think about when you throw something, I will write in yellow what the path looks like. It's going to go something like this, right? You're going to throw it. It's going to go to a highest point, the vertex, and then it's going to drop down. Well, if you look at that shape I just drew, that's a parabola that opens down, so my a value would have to be negative. So the h out front, that's the height. So if it says, how long will it take to hit the ground? Well, that's when you set it equal to 0. Now, t is the time in seconds. H sub O, that's the starting height, the initial height. So if it's thrown off the ground, then your H sub 0 equals 0. Last but not least, our V, our V sub 0, our initial velocity, is pretty much how far you're launching at. So if it says like I'm throwing a baseball at 30 feet per second, that would be my initial velocity. So the initial velocity, it's positive if we throw it up. Our initial vertical velocity is negative if we throw it down. Well, we have a positive we have a negative, so it's positive if we throw it up, negative if we throw it down. Now, think about when you throw something. If I throw something down, if I'm on the second floor of Logan High School and I see someone I want to throw a football at them, I initiate force when I throw that thing down. However, I could just drop something down. So I could have an initial vertical velocity of 0, and that's when we drop it down. Again, that has no starting velocity. So why does it go down? Well, because of gravity, and that's where that negative 16 kicks in. No starting velocity. Okay, so we have a word problem now. And again, on a quiz or test, I will be supplying this equation to you. You do not need to memorize it, but you will, however, need to plug something in. So in other words, on a quiz or test, I would supply you with probably this, and you would need to, plug in the values. Okay, so this says, the water in a fountain leaves the spout with a vertical velocity of 30 feet per second. After going up in the air, it lands in a basin 6 feet below the spout. If the spout is 10 feet above the ground, how long does it take a single drop to travel from the spout to the basin? So, is our object being launched or is it being dropped? Well, if it's being shot out of a fountain, it's going to be launched out. So our equation is H equals, you can see this on the top of your page, H equals negative 16 t squared plus our initial velocity times t plus our starting height. Okay, so let's list out what we know. Well, we got to figure out what our H value is, what our T value is, what our H sub 0 is, what our starting height is, and our V sub 0, our starting velocity. So again, what does H stand for? The height in feet. So if we look on here, does it say anything about the height in feet? Well, it says something about 6 feet here. So it says, after going up in the air, it lands in a basin 6 feet below the spout. So it's shooting up in the air and it's landing 6 feet below the spout. So it's landing right here. If the spout is 10 feet off the ground, so it's 10 feet here, this is 10 feet in the air, and this is 6 feet in the air, well, how long does it take? How long is that blue line? If it starts at 10 feet and ends 6 feet below it, well, it travels down 4 feet. 10 minus 6 is 4. And how do we get that again? 10 minus 6. Okay, let's go through and look at our other information we're given. So it says with a vertical velocity of 30 feet per second. Is that our starting height or is that our velocity? Well, feet per second, that would indicate velocity. So it's 30 feet per second. That tells us our starting velocity. And again, now we either got to find T or H sub 0. H sub 0, that tells us the starting height. So what's the starting height of this fountain? Well, it says the spout is 10 feet off the ground. Our starting height is 10 feet. So now all we need to do is plug these values into the equation, but we don't know what T is. Well, what does our question ask? Our question asks us, how long does it take for a single drop to travel from the spout to the basin? So in other words, we don't know what T is, and that's what we're trying to find. So our equation says H. Well, our H value is 4 equals negative 16. We don't know what T is. T squared plus the starting velocity. Well, what's the starting velocity? Plus 10t, plus 30t, plus our starting height is 10. So now we need to ask ourselves, well, how do I get H? How do I solve for T? Well, I got to use the quadratic equation to do this. And again, the quadratic equation is the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. But this only works when I have my variable set equal to 0. So right now it's set equal to 4. So I got to move over this, 4 minus 4 minus 4. And now I have 0 equals negative 16t squared plus 30t plus 10. So now, plus 6. 10 minus 4 is 6. Sorry, people. Plus 6. So now I can list out my A, B, and C value. A, B, and C. My A value is attached to my t squared, so it's negative 16. My B value is 30. And my C value is 6. So now I just need to plug these into the quadratic equation. So I get the opposite of my B value. Well, the opposite of 30 plus or minus the square root of B squared, so 30 squared minus 4 times my A value, negative 16, times my C value, my C value 6, all over 2 times A, and A, is negative 16. Okay, so now, again, I'm going to reduce what's underneath of here. So I'm going to say, well, this is really negative 30 plus or minus the square root of 30 squared is 900. Now I need to do negative 4 times negative 16 times negative 6. So negative 4 times negative 16 times 6 would give me positive 384 all over negative 16. Okay, now I can say, well, 900 plus 384, that is negative 30 plus or minus the square root of 1,284 all over negative 32. Now you can reduce the square root of 1,284. I'm going to go way over to the left over here, so I'm going to go like this just to save some room. And now I should get negative 30 plus or minus 35.83 over negative 32. Well, now I need to do two separate problems again. So I need to do negative 30 plus 35.83 divided by negative 32. And then I need to do negative 30 minus 35.83 divided by negative 32. Now, before we solve this, let's take a step back. This says, my question is asking me, how long does it take a single drop to travel from the spout to the basin? So let's think about this logically. If I'm trying to find time, can time be negative? Well, no, it can't. So one of these answers is going to give me a negative answer. So I'm dividing by a negative 32. So if I want a positive answer and I'm dividing by negative 32, I can't have a positive on top. So if we look on top, the black equation, negative 30 plus, if I did negative 30 plus 35.83, I would get a positive number divided by negative 32. A positive divided by a negative, that would give me a negative answer, and it does not work. I don't want the negative answer. So when these parabolas, they're going to give us two answers. We can only use one of them in word problems most of the time because one of the answers they give us won't make sense. I can't have time be negative. Okay, so now what I can do is say, well, negative 30 minus 35.83, that's going to give me negative 65.83 divided by negative 32, which equals 2.05 or 2.06, I think it is. I'll say 2.057, and that is seconds. Again, these problems, I will supply the equation to you. One more note I want to make about these last 2 days of notes. You are not necessarily being tested on the quadratic formula. It's something that I need to teach you. It's something that you should have learned last year. I can guarantee there will be one type of question that involves the quadratic formula on your final. there might be a problem that talks about the discriminant on your final. So that would be a problem like number 1 or number 2. There might be something that involves a word problem on your final, but you will not be quizzed or tested on this material. With that being said, you still need to complete the homework assignment. That's going in as I believe, a 10-point homework assignment. You should have half of it completed from yesterday. That assignment, front and back, will be turned in Monday for a grade. If you have any questions, feel free to email me. Otherwise, I will see you on Monday.